Very good morning. Today we are going to discuss about passing package number 6. That's a carbon and its compounds. It's a big chapter in our syllabus, and also on this chapter 6 to 7 or 8 marks comes in exam. That's why we are going to discuss about this chapter. Okay, you already know the carbon atomic number 6, atomic mass number 12, and its symbol is C. Symbol is a C. Then electronic configuration 1s2, 2s2, 2p2. Then valence electrons are 4 valence electrons are there. Then valency also 4. Valency also 4. Why? Because to complete a p level, how many electrons are required? 4 electrons are required. That's why valency is 4. Okay, combining capacity of an element is called as a valency. Then what carbon reacts with a hydrogen and form its compounds. Okay, hydrogen atomic number 1, atomic number mass number also 1, electronic configuration 1s1. It also reacts with oxygen atomic number 8, atomic mass number 16, electronic configuration 1s2, 2s2, 2p4. Okay, that's why oxygen's valence electrons are 6 and valency 2. Oxygen valency, carbon's valency is 4, oxygen's valency is 2, and hydrogen's valence is 1, because 1s1. To complete s level, how many electrons are required? 1 electron is required. That's why its valence is 1. Then some important questions we are going to discuss. How are covalent bonds are formed? The bonds formed by sharing of electrons, those are called as a covalent bonds. The bonds formed by transferring of electrons or exchanging of electrons, that's called as a ionic bond. Okay, we already discussed the difference between covalent bond and ionic bond. Okay, next, write the properties of covalent bonds. What are the properties of covalent bonds? Covalent bonds have a low melting point and boiling point. Okay, they have a low melting point and boiling. Maximum all covalent compounds are they are in molten solid state, or they are in liquid state, or they are in gaseous form. That's why low melting point and boiling point. Low melting and boiling point. Covalent compounds are generally poor conductor of electricity. Why? Because they not liberate electrons at a solution states. They not liberate their ions at a solution state. That's why they are poor conductor of electricity. Then covalent bonds are generally volatile in nature. Generally what they are volatile in nature. Okay, this is a 2-mark question, very important 2-mark. Write the properties of covalent bond. Next, what do you mean by tetravalency? Okay, it has a 4 electrons in the outermost cell, hence its valency is 4. That's a tetravalency. The combining capacity of a carbon is 4, that's why it is a tetravalent element, or it's called as a tetravalency. Explain catenation. 1 mark, very important question. It's a 1 mark, very important question. The property of self-linking of elements, mainly carbon atoms, through a covalent bonds to form a long or straight or branched chains and rings of different sizes is called as a catenation. Next, whenever we are writing the structures of carbon compounds, straight chain, branched chain, and it's a closed chain. Straight chain, branched chain, and closed chain. Whenever we convert a straight chain into branched chain, the physical and chemical properties changes. Whenever we convert a straight chain into closed chain, the physical and chemical properties molecular formula remains same, but structural formula changes. Then mention the difference between unsaturated and saturated compounds. We already discussed in differences, but again we have to discuss. But only one bond is present in between carbon to carbon atom. It is called as a saturated hydrocarbon. Double or triple bond is also present in between carbon atoms. It's called as an unsaturated hydrocarbon. Substitution reaction occurs. Addition reaction occurs. Okay, then it burns in a blue flame. It burns in a sooty flame. Which one? Unsaturated hydrocarbon. Write the general formula of alkane, alkene, and alkyne. Alkane CnH2n plus 2, alkene CnH2n, alkyne CnH2n minus 2. If you want to remember, alkanes double plus 2, alkenes exactly double, alkynes double minus 2. Double minus 2. It's a easy way. Okay, whenever we are writing the general formula in structural formula. What is esterification reaction? What is a esterification reaction? When ethanol reacts with acetic acid in presence of sulfuric acid catalyst, a fruity smelling substance called ester is produced. This reaction is called esterification. If you don't want to read this question, neglect it. Why? Because whatever the 20% reduces syllabus, in that they remove this one. Next, draw electron dot structure for ethanoic acid, then hydrogen sulfide, then propanone, then which one? Iron, then carbon tetrachloride, carbon dioxide. Carbon dioxide. These are the some compounds we want to write electron dot structure. For example, first one, ethanoic acid. Ethanoic acid is a carboxylic acid. Ethanoic acid is a carboxylic acid. C2H4 C2H3 C2H3 COOH. It's a carboxylic compound. C2H3 COOH. Okay. Then this is a molecular formula. This is a structural formula. In between carbon atoms and hydrogen atoms, sharing of electrons occurred here. Sharing of electrons, wherever you are seeing here, sharing of electrons. In between carbon atom also, carbon atom, sharing of electrons, and in between oxygen atom also, then hydrogen atoms also. Okay, this is what ethanoic acid's electron dot structure. Then hydrogen sulfide. Hydrogen's valency is 1. Then sulfur's valency is 2. That's why what in between sulfur and hydrogen, electrons are shared, and like this electron dot structure is formed. Next, which one? Propanone. Propanone, it's a one ketone. Okay, how many carbon atoms are there? 3 carbon atoms are there. C3H6CO. C3, C3H6O. Or we can able to write C2H6CO. Like this also we can able to write. Next one, fluorine, F2. Okay, sharing of electrons, it's a electron dot structure. Carbon dioxide, okay, electron dot structure. Then carbon tetrachloride, it's a what? Organic solvent. It's what? Organic solvent. It's dot structure. Carbon shared its electrons, 4 electrons with chlorine, 4 chlorines, CCl4. Okay, definitely 2 marks comes on electron dot structure. Write the molecular formula and structural formula of methane, ethane, propane and butane. They asked. That's why what? Methane, CH4. Okay, CH4, it's a molecular formula. Then structural formula, carbon shared 4 electrons with hydrogen. That's why single bonds are formed. Next one, ethane. C2H6. This is the structural formula. Propane, C3H8. This is the structural formula. How many carbon atoms are there? 3 carbon atoms are there. How many hydrogen atoms are there? 8 hydrogen atoms are there. 1, 2, 3, 4, 5, 6, 7, 8. Next, butane, C4H10. Okay, this is the molecular formula. This is the structural. If you practice some alkanes, alkynes, if you already practiced based on their general formula, molecular formula and structural formula, they are very easy. Next one, double plus 2 alkanes. Now exactly double alkenes. First one compound in alkenes, ethene, C2H4. Okay, in between carbon double bonds are there. It's ethene structure. Next one, propane, C3H8, C3H6, exactly double, C3H6. This is the structural formula. Okay, we have to maintain here what? 4 bonds. That's enough. Next, butane, C4H8. This is the molecular formula, structural formula. Next, alkynes, double minus 2, C2H2 ethane, in between carbon and carbon triple bond is there. This is the molecular formula, structural formula. Next, propane, C3H4, C3H4. How many carbon atoms are there? 3 carbon atoms are there. Anywhere you have to write a triple bond and 4 hydrogen atoms. 4 hydrogen. Next one, butene. Butene C4H8. They made a mistake here. It's okay. Butene C4H8. C4H8. How many carbon atoms are there? 4 carbon atoms are there. Anywhere. What you have to write one place, triple bond. Other than this, how many hydrogen atoms are there? Butene. Double minus 2 C3H6. This is also they made wrong. C3H6. Structural formula correct is there. Structural formula correct is there. Then what is a homologous series? What is a homologous series? Explain with an example. A series of similarity constituted compounds in which the members present have the same functional groups and similar chemical properties, and any two successive members in a particular series differ by a CH2 units. It is called as a homologous series. In Kannada, anurupa shrenigalu. Okay. Then Alkene series, if you taken CN H2N plus 2, methane, ethane, propane. These are homologous series. How, sir, we can able to prove also C2H6. What it's a? It's a ethane. What it's a? Ethane. CH4. What it's a? Methane. Then we substitute in ethane. What in ethane we substitute a methane. Then the remaining thing is a CH2. Remaining thing is a CH2. That's why it's called as a homologous series. Write the structure of benzene and cyclohexane. Very, very important. Write the structure of benzene. How many carbon atoms are there? 6 carbon atoms are there. 6 hydrogen atoms are there. Okay. In where? Benzene. That's why for a 6 carbon atoms, we arranged a 6 hydrogen atoms. 6 hydrogen atoms. And what 3 bonds are formed to arrange the Tetra Valency form. What we done here, what alternatively double bonds. Alternatively double bond. We can able to write like this also structure of a benzene. Next, cyclohexene. Cyclohexene, how many carbon atoms are there? 6 carbon atoms are there. 12 hydrogen atoms are there. For each carbon, 2 hydrogen atoms. For each carbon, how many hydrogen atoms? 2 hydrogen atoms, and in between carbon and carbon 2 bonds are there. That's why it's a cyclohexane and benzene. Very important structural formula. Sometimes they ask which one? Toluene in exam. CH3. This is the structure of toluene. Write the uses of acetic acid. Okay, it is used in preservative. It is used as a preservative in pickles. Then it is used in the synthesis of esters. Okay, 2 mark question, very important. Write the uses of acetic acid. What are the isomers? Give example. Carbon compounds having some molecular formula but different structural formula, those are called as isomers. Here they given I think butane. Butane's molecular formula and structural formula. Molecular formula C4H10. C4H10. This is a straight chain. If you make a branched chain, okay, that's an isomer. That's a isomer. What is a functional group? Name the different functional groups. Functional groups may be defined as what is a functional group? Name the different functional groups. Functional groups may be defined as an atom or a group of atoms which makes carbon compounds or organic compounds reactive and decide its properties regardless of length and nature of carbon chain. It's called as a functional group. Then name the different functional groups. What are those functional groups? Okay, chlorine and bromine, heteroatom. Chlorine and bromine are heteroatoms, and those class of compounds are haloalkanes. Okay, and they are pronounced as a chloro or bromo. Formula of functional groups ClBr. Next one, oxygen oriented heteroatoms are alcohols, OH, aldehydes, CHO, then next ketones, CO, then carboxylic acids, COH. These are the different types of functional groups. Okay, sometimes we use as a prefix, sometimes we use as a suffix. Next, list the uses of ethanol. Ethanol is used in alcoholic drinks. It is useful in tincture of iodine cup syrups, and what other tonics. Alcohol is used as an additive to petrol since it is a cleaner fuel and gives only carbon dioxide and water on complete combustion. Next, name the following compounds. Name the following compounds. How many carbon atoms are there? 3 carbon atoms are there. Okay, 3 carbon atoms are there, 6 hydrogen atoms are there, and 1 oxygen atom is there. That's a propanol. That's a propanol. Then 4 carbon atoms are there in second one. 4 carbon atoms are there. Then 8 hydrogen atoms are there. 8 hydrogen atoms are there, and oxygen. It's called as a butanol. It's called as a butanol. The next one, HCOH. HCOH. It's a methanoic acid. It's what? Methanoic acid. Next, name the following compounds. Name the following compounds. How many carbon atoms are there? 3 carbon atoms are there. Okay, that's why it's a propane. Propane. Functional group is a OH. That's why alcohol. Propanol. Propanol. Alcohol functional group. Then next one, how many carbon atoms are there? 3 carbon atoms are there. And functional group COOH. That's a prophenoic acid. Carboxylic acid. It's a. Next, which one? Chlorine is a functional group. How many carbon atoms are there? 3 carbon atoms are there. That's why chloropropane. Chloropropane. Next one, propanol. Propanol. CHO is a functional group. How many carbon atoms are? 3 carbon atoms are there. That's a propanol. Next one, propane. Next one, propane. How many carbon atoms are there? 3 carbon atoms are there. And in between carbon, one single bond is there. One triple bond is there. That's why it's a profine. Profine. What? C3H4. That's enough. C3H4. Next one, butanone. Butanone, it's a ketone. It's a ketone. Functional group is a CO. How many carbon atoms are there? 4 carbon atoms are there. Okay, that's why butanone. It's a butanone. Why carbon usually doesn't form an ionic bond with other carbon atoms or other elements? Carbon needs to gain or lose 4 electrons to attain a noble gas electronic configuration. First one reason. It's a what it is. What if it gains 4 electrons, forming a 4 anions? It would be difficult for the nucleus with 6 protons to hold on. 10 electrons means attraction force of electrons is not sufficient to hold 8 electrons in a valence shell. Next, if it loses 4 electrons, if it gains, what happens? I explained. If it loses 4 electrons, okay, 4 cations are formed. It would require a lot of amount of energy to remove 4 electrons from its valence shell. That is not easily available in chemical reactions. Hence, carbon doesn't form an ionic bond in any atoms. Maximum it not forms a ionic bond. Explain the formation of single covalent bond between hydrogen atom, 2 hydrogen atom, and write electron dot structure. Hydrogen's atomic number is 1. Electronic configuration 1s1. That's why its valency is 1. Whenever the hydrogen reacting with hydrogen, then it share one pair of electrons. One pair of electrons. That's why hydrogen reacts with hydrogen. It gives a hydrogen molecule. Then hydrogen molecule, they've shared both in between electrons. That's electron dot structure. Write the electron dot structure. Explain the formation of covalent double bond between 2 oxygen atoms. Oxygen atomic number 8. Oxygen's mass number 16. Electronic configuration 1s2, 2s2, 2p4. That's why its valency is 2. That's whenever oxygen reacts with oxygen, it share a 2 pair of electrons. It share a 2 pair of electrons and form a 2 covalent bonds. 2 covalent bonds. Oxygen reacts with oxygen and gives oxygen molecule. This is the electron dot structure. Here also they given electron dot structure O2. Next, with the electron dot structure, explain the formation of covalent triple bond between 2 nitrogen atoms. Nitrogen atomic number 7. Electronic configuration 1s2, 2s2, 2p3. So its valency is 3. That's why whenever nitrogen react with nitrogen, it shares up 3 pair of electrons. 3 pair of electrons. This is an electron dot structure. Electron dot structure. Okay, formation of methane, CH4, electron dot structure. 4 carbons, 4 electrons are shared with hydrogen and forms a methane. Define isomerism. Write the structures of butane structural isomers. Organic compounds with same molecular formula but different structural formula are called isomers. The phenomenon is called isomerism. Butane, normal butane, N-butane we also called. Okay, N-butane, C4H10. Then isobutane, there also C4H10, but the chain is branched. Write the functional groups of alcohol, aldehyde, ketone and carboxylic acid. Alcohol OH, aldehyde CHO, ketone CO, carboxylic acid COH, Then write the difference between alkenes, alkenes and alkynes. Okay, these have a carbon atom single bonds, carbon single bonds. Alkenes, these have a carbon double bonds along with the single bonds. These have at least one carbon triple bond along with the single bonds. Then alkanes general formula CnH2n plus 2. Alkenes general formula CnH2n. Alkynes general formula CnH2n minus 2. I already said for you shortcut. What? Alkanes double plus 2. Alkenes double. Alkynes double minus 2. They are saturated. Alkanes are saturated hydrocarbons. Alkenes are unsaturated hydrocarbons, and alkynes also unsaturated hydrocarbons. Next, define oxidation. The process of addition of oxygen or removal of hydrogen is called as a oxidation. For a ethyl alcohol C2H5OH, okay, we use a alkaline potassium permanganate plus heat, or we use acidified potassium trochromate plus heat. What it gives? It gives a acetic acid. Then alcohols can be oxidized to carboxylic acids by heating them either in presence of oxygen agents. The substance which provide oxygen to other substances is called oxidizing agent. Here alkaline potassium permanganate or acidified potassium dichromate acts as a oxidizing agents. Mention 4 differences between saturated and unsaturated hydrocarbons. Only single bond is present in between carbon-carbon atoms, where in saturated hydrocarbons, and in unsaturated hydrocarbons double or triple bond is also present in between carbon atoms. Then saturated hydrocarbons, substitution reaction occurs. Unsaturated hydrocarbons, addition reaction occurs. Saturated hydrocarbons, it burns with a blue flame. Unsaturated hydrocarbons, it burns with a sooty flame. Then saturated hydrocarbons less reactive, unsaturated hydrocarbons are more reactive. Write the molecular formula and structural formula of methane, ethane, propane and butane. We already wrote those. Which one? Methane, ethane, propane, butane, like that only. Ethene, propane and butane. We already studied these structures. What is the addition reaction? A reaction in which simple molecules added to unsaturated compounds to form a single product. It is called as a addition reaction. Here we use as a nickel or palladium as a catalyst and hydrogen for additional reactions. What is a substitution reaction? Give example. A reaction which involves the direct replacement of atom or a group of atoms in which organic molecule by other atom or group of atoms without any change in the rest of the molecule are called substitution reaction. Example, methane reacts with chlorine. Methane reacts with chlorine. It gives a chloromethane and hydrochloric acid. How micelles are formed? Explain cleaning action of soap. Soaps are molecules in which the two ends have a differing properties. One is a hydraulic, and then that is dissolves in water. With other end is a hydrophobic, that is dissolves in a oil or dirt. This unique orientation is called micelle. Science oil. or dirt will be collected in the center of the micelle. It is easily rinsed away from clean cloth. For example, here oil is there. Okay, this is the positive end and negative end is connected to oil. Okay, whenever we rinse the cloth, these micelles will come outside. In hard water, detergents are acts as a cleaning agents. Give reason. Because the hardness of water is due to the presence of calcium and magnesium salts in hard detergents do not form insoluble precipitates which calcium and magnesium ions. Thus detergents are better cleaning agents than soaps in hard water. These are the important questions I discussed with you. Very important chapter. It's a carbon and its compounds. Maybe up to 5 to 6 marks definitely comes in exam. So ಇದನ್ನೇನು ಮಾಡ್ರಪ್ಪ ಅಂದರೆ ನೀವು ಆಡಿಯೋ ನೋಟ್ಸ್ ಅಂತ ತೆಗೆದುಕೊಂಡು ಹೌದಾ ಅವಾಗವಾಗ ಕೇಳ್ತಾ ಇರ್ರಿ. ಹೌದಾ ಅವಾಗವಾಗ ಏನು ಮಾಡಿರಿ ಕೇಳ್ತಾ ಇರ್ರಿ. ಕೇಳಿ ಏನಪ್ಪ ಅಂದರೆ ಚೆನ್ನಾಗಿ ನಿಮ್ಮ ಎಕ್ಸಾಮ್ ಪ್ರಿಪೇರ್ ಆಗ್ರಿ ಅಂತ ಹೇಳ್ತಾ ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್.